In example 2, we'll look at how the variables in each graph are related. So in example A, you can see down here where the input, this is the miles driven, and the output is the cost to rent a car. So the cost to the cost depends on the number of miles driven. And we can go even further and say that for the first blank miles, so for the first section of miles, the cost doesn't change. So the cost is unchanged for a given number of miles. And then it increases, and then the cost increases at a constant rate. So there's going to be a set charge for, say, the first 100 miles, and then once you go past that, you might charge, they might charge like 50 cents per mile or something on that. So it's going to increase depending on how much you've driven. In example B, for this one, we can see that the input will be the weight of a package, and the output is the shipping cost. So again, cost this time, though, depends on weight. Now you can take a look at this graph and see that it's not a constant increase. So it's not increasing like at 20 cents per ounce or anything. It's not constant. It is has these straight lines. So think for a minute what you think that might mean. So you can see the open dot here on the y-axis. So that means that if you don't have any ounces, it's free. But then to the right, you can see that for the first section of ounces, so maybe for 0 through 10 ounces, there's a constant cost, and then it hops up, and then maybe at 11 through or 10.0001 through 20, it's going to have an increased cost, and then hops up again. So the cost depends on weight, and it steps up in sections. So there. Example 3, I'm going to leave, and we're going to do that for our video check. So I'll go to example 4. Considering the following situation: diet, exercise, and genetic factors, according to today's doctors, can affect a person's blood cholesterol level. Since a person has some control over diet and exercises, these factors or variables can be described in terms of dependence. Which of these quantities depend on the others? So I've got the amount of LDL, which is bad cholesterol, number of hours of aerobic exercise, and amount of saturated fats consumed. So the ones that we have control over, which is the number of hours of exercise that we do, would be our independent. So this is going to be an independent variable. We can choose how much we want to do, as well as how many saturated fats we consumed. We could also make those decisions as well. Nobody's forcing it down our mouths, so we choose to eat whatever saturated fats that we put in our mouth. So those are independent. Then as a result, the bad cholesterol supposedly will go up. So this is going to depend on the others. So I'll say that it's dependent. So I'll make a statement: LDL cholesterol depends on amount of exercise and fats that we eat.